Alrighty guys, so what is going on? Ains Covers here and welcome back to another news cover. Today we're doing Scientists Discover How to Trap Mysterious Dark Matter by Paul Ratner. I'm also going to leave a link to the article in the description below in case I do not read all of this, because I don't know if I will, and if I mess up enough I'm just going to stop the video because I'll get better over time, but let's do this. A new method promises to capture an elusive dark world particle. Scientists working on the Large Hadron Collider LHC devised a method for trapping dark matter particles. Dark matter is estimated to take up 28.6% of all matter in the universe. The researchers will be able to try their approach in 2021 when the LHC goes back online. After finding one mysterious particle, the Higgs boson, scientists working with the Large Hadron Collider are looking to discover another needle in the haystack. Dark matter. It is supposed to be quite well dispersed around us. In fact, dark matter is estimated to take up about 26.8% of all the content of the universe. The other 68.3% is gobbled up by dark energy, and no less mysterious conjecture. Both are essentially keeping our universe bound together. Normal matter, if you are wondering, takes up about 4.9% of everything, not all that much for the part that includes us. One big problem with dark matter, no one has seen it. We just know of it from its effects, like seeing how gravity affects it. How to finally spot dark matter directly is what scientists from the University of Chicago were looking to figure out in their new paper. They came up with a novel method for trapping dark matter in the Large Hadron Collider by taking advantage of the dark particle's lower speed. The study was concluded by Lien-Tao Wang, a University of Chicago professor of physics, UChicago, postdoctoral fellow Jia Liu, and Fermilab scientist Zheng Liu, now at the University of Maryland. We know for sure there's a dark world, and there's more energy in it than there is in ours, said Liu-Tao Wang. The theorists propose that one kind of dark particle is heavier and slower and sometimes interacts with normal matter. It also has a somewhat longer lifetime of up to 1/10 of a second. So scientists believe that these are occasions in each decade when such particles can be found with proton collisions engineered at the LHC. In a press release, Wang explained that these special dark particles could be coupled to the Higgs boson in some fashion. This would make the Higgs boson a portal to the dark world, said Wang. One possibility is that the Higgs actually turns into these longer-living dark particles as it decays. What is dark matter? Michio Kaku explains. But how to trap the dark particle among the billions of collisions happening at the LHC every second? Liu, the first author of the study, thinks that such a dark particle would be heavier and thus travel slower than the speed of light that would keep it separated from the others. The method devised by the scientists would zero in on such particles that decay at a lower rate. The difference could be as small as a nanosecond or even smaller, but the sensors of the LHC, already an amazing machine, will be able to detect such anomalies. Liu believes the LHC has the capability to try their idea out and find the particles. One problem, however, their team will have to wait. Most famous for the discovery of the Higgs boson particle, the Large Hadron Collider, the world's largest scientific instrument, is currently offline. It is undergoing improvements that will give it a power boost. When it goes back online in 2021, the LHC's energy output will be 1 trillion electron volts higher at 14 trillion volts. So right now it's at 13. With the extra power, the Swiss-based 27-kilometer collider operated by CERN can help us find dark matter, argues Liu. We think it has great potential for discovery, he said, adding, if the particle is there, we just have to find a way to dig it out. Usually the key is finding the question to ask. Wow, I actually thought I was scrolling down. I thought it was longer than this, but guys, that is actually it for this. So, like and afraid if you enjoyed, subscribe, and I will see you guys in the next video. Peace.